fuck if I want to read studies, man? I want to know what's right and what's wrong so I can get fucking jacked and lean so somebody can finally pay some fucking attention to me, for the love of God. I don't have any friends. This is the stupidest shit I've ever heard in my life. If that kid was president, I would fucking assassinate him. That would be my job as a kid.
Welcome to my channel.
The Lifting Dermatologist, Steven DeVos.
Steven DeVos.
He's got a ton of great stuff.
A Belgian doctor with 30 years of weightlifting experience and the author of Flexibel Dieet en Krachttraining. If you want to learn more about fitness and nutrition, hormones and anti-aging,
please like and subscribe.
All this to optimize your life overall. I also invite you to join my other YouTube channel TRT and Hormone Optimization. The link you can find in the description of this video. Welcome everyone to the video. Today I have as honored guests Dr. Mike Israetel and Dr. Jordan Grant. Welcome guys.
Thank you.
Thanks for having us.
Welcome. Last week I had Dr. Jordan interview Broderick Chavez. That was one of the guys he wanted really to ask some questions about PEDs, hormones and so on. And he also had a lot of questions for Dr. Mike Israetel. So I let you go at it, Jordan.
Thank you, Stephen. Yeah, thanks, Mike, for coming on. I guess what prompted this was, and this has nothing to do with PEDs, so we're not going down that road. We, in our Facebook hormone group, we are always looking at papers, trying to, cipher through a lot of crap, what's right, what's wrong. More on the side of hormone stuff, but we talk about training and not being trained in statistics or doing research. This stuff it's like a minefield. And I just wanted to have Dr. Mike on to talk about, at first, just basics in research, especially with exercise science, sports science, because I'm fascinated by that stuff too, and how that stuff is structured. And then we can kind of, at the end, I just wanted to get general tips for all of us lay people, if possible, on how to better look at studies, decide, was it done halfway decently? What are some things that we need to be looking for? Because I think a lot of guys will just Google search stuff and they'll post an abstract and the findings and then not actually ever dig into the details of it. Like, how was it done? Who was it done on? Is it even relevant? And so I just wanted to kind of talk about those things. What kind of prompted this as well, I watched the debate that Mike did with Lyle McDonald. I guess it's almost a year ago on Revive Stronger about the volume paper. And it's fascinating, and we all know Lyle is a smart guy, but man, it was almost depressing because he's focusing on these just minutia, tiniest little things and p-values. And I don't want to necessarily get into all that. But it just made me realize like how much goes into this stuff and how complicated it is and how hard it is for us normal folks to even, what do we take from these things? When can we look at a study? And
just on that note, the real bad news for Lyle is that numerous studies have since come out and replicated the findings of this earlier one. Yeah. And in addition to that, a very parsimonious explanation for much of the, though not all, much of the difference in the volume literature between the studies that find 20 to 30 or even more sets per week being a good idea versus studies that find 10 to 20 was offered by James Krieger in his latest research review, and that's rest times. And Lyle didn't catch that one. It just decided to call James Krieger names and bring up pointless critiques that went nowhere, and now that multiple studies have confirmed the findings of this original, which wasn't even the original. This study was a replication. The Schoenfeld study was a replication of another study, which also found the same thing. And so it's funny, like all of that effort to sort of factored into disbelief. That's where that effort was. It was so difficult to change one's worldview because of some study that he took, moved heaven and earth to try to refute it. In reality, never actually had to alter his worldview. He just had to understand that rest times were the big deal there to some extent, though not all. And he never came up with that because he was so busy just losing his mind over the study. So there's a lesson in there, and it's that one study hardly means a thing, but I'll get to that later.
Yeah, and I'll definitely bring that up. And I also want to talk about this issue of people not being willing to change their, I guess, have a paradigm shift when the evidence starts pointing in a different direction. And that's something that I harp on when I make posts on our Facebook group. Like, listen, guys, you got to be willing to follow the evidence, even if it leads you down an uncomfortable path that questions your beliefs on whatever it is. This is politics, religion, sports science, nutrition, it doesn't matter. But that's kind of what we're talking about this today, to figure out when is it good evidence and when is it worthy to look at changing your mind instead of just jumping on the first study. So I guess we'll start real quick with just kind of just a basic intro. And I know you've done this on podcasts before, but what got you into, or how did you start out with sports science? Well, I guess sports science versus exercise science, is there even a difference in those two things?
So my PhD mentor, Dr. Mike Stone, would say there's a huge difference, and he'd probably be correct. Exercise science is using exercise as a lens by which to study physiology and anatomy and biomechanics and so on and so forth. So for example, if you are interested in designing, in trying to understand the dynamics of the knee joint very, very well, with eventual potential applications in robotics or surgery, or you're not even so much worried about it, you really want to understand the knee, you might use squats or cycling or walking to study the biomechanical relationships of the knee to other structures and within itself. That would be exercise science, because you're using exercise. If those people use a walking protocol or a cycling protocol, you catch the researcher in his off hours, you're like, hey, do you have any tips for me trying to become a better cyclist? He'd be like, no, I use cycling to find out how stuff works. I don't use how stuff works to find out how to make you a better cyclist. So the opposite of that is sports science. So exercise science is trying to use exercise to figure out how science works, physiology, anatomy, so on and so forth, whereas sports science uses the lessons of exercise science to try to ask the question, how do we become better at various aspects of sport? So a sports science is by definition more applied than exercise science, and exercise science is much more theoretical.
Broad, yeah, and they use that to go down lots of different avenues, medical, sports, all those. Okay.
100%. So if you come up to an exercise science and you're like, hey, how do I train? He's going to be like, man, he might tell you some stuff, but it's not going to be anything that great in many cases. You come up to a sports scientist and he's going to have a whole lot to say, because that's his entire body of knowledge is taking physiology, anatomy, so on and so forth, and factoring them into, okay, how do we train for better sport?
That's interesting. That's a good point, because, I mean, we even see that when I've talked to physical therapists before, or doctors, and we learn some of the mechanics and the anatomy and all that, but that doesn't mean we know how to apply it to sports at all. Sure. Okay. Is there a pretty big gulf, and this not just with sports science, exercise science, but between the two, or do they work pretty closely together, I guess, as far as?
So I would say there's kind of like a bimodal distribution. It looks something like this. So there's a big middle area that's still non-zero of people that dabble in both. I would say, for example, Brad Schoenfeld does a lot of stuff with application and concerned with training, but also does a lot of mechanistic research and is involved in stuff trying to figure out how muscles grow, period, with just trying to understand how they grow, which is more exercise science. Okay. And we use training in order to understand how muscles grow, so maybe we'd eventually learn some other stuff from it. So I'd say Brad Schoenfeld is mostly a sports scientist, but has a lot of exercise science stuff that he does. Then there's other people further down that, which are really sort of world experts in muscle mechanics and cellular pathways, but they mostly study individual cells and rats, and they can't write you a program. They would never tell you they could write you a program, but Brad Schoenfeld reads their papers, and they have some understanding of training, but very limited one. And then way down the other end are people who do, individual protein assays and studying the myosin globular head, and they don't know dick, or they might not even know what lifting is, for the love of God. That to them it's just applying resistance. And you could say, hey, what's better for muscle growth, like lifting or sprinting? And they'd be like, man, they both apply resistance. That's all I know about it, right? So it's one of those things where they're on the extreme end, and then all the way on the other end, we have folks, probably such as myself, who's very, very concerned with performance and very, very concerned with results, and uses as much physiology as needed to get there. Gotcha. So that would be, so there's everyone's, it's a spectrum, right? And some of those people talk to each other, but some really don't. There are some sports scientists who know only enough physiology that is required to extract performance outcomes. Like they can tell you exactly what sprint protocols are great for increasing sprinting, and they know they know how it has something to do with creatine phosphate and so on dynamics. But if you test them, like, okay, tell me everything you need to know about the phosphagen system, they'd run out of steam in about 15 minutes. But there's other guys who like literally discovered the creatine phosphate system and are always studying it, who are like, oh, tell me about sprinting. And they're like, well, it's going to use creatine phosphate. And they're like, what else? Like, fuck I know, right? And there's no real beef between those two.
Right.
It's a spectrum, and some people are parked on various ends of it. Some people travel a little bit, but the important thing for the consumer of science is when you're reading something by someone, or you want to know something from someone, know where they are so you can ask them the right kind of questions. Like if I have an exercise physiologist that I get a chance to talk to, I'm going to ask him about deep mechanisms. I'm not going to ask him how many sets and reps to do. If I have a sport physiologist versus an exercise physiologist, a very pure sport physiologist, I'm going to be like, listen, these two protocols, which one's better for increasing sprint speed or jump height, and why? I'm not going to be like, so what do you think about like the creatine phosphate pathway? He'd be like, well, I can tell you some stuff, but it won't be much.
Yeah, I mean, it's similar in our world where somebody starts pimping me on, hey, tell me the Krebs cycle. It's like, well, I learned that back in med school, but it's not relevant. It's, we all have our roles. And so you're, as sports scientist, it's more of a, for lack of a better term, pragmatic approach to let's find what works. And it's fun to know why, but there's all these other layers, and they're kind of finding out the why on one end.
Yeah, so I would say pure sports science is very pragmatic, but not very insightful, because you gain insight by examining deep mechanisms. Yeah. So exercise scientists generate the insight, and sports scientists correlate the insight to make it very applicable. For example, a NASA engineer who's building space shuttles or something, I suppose NASA doesn't build space shuttles. So an engineer at Lockheed Martin who's building parts of spaceships knows the materials he needs, knows their dynamics well enough to understand that the tolerances and weights are concomitant with building a spacecraft, and that's all he cares about. Now, he knows a lot about material science, but he really knows building space shuttles. Material scientists design all those components. They might know dick about going to space. It's not like, what do you think about space? Like, well, I guess our stuff could go to space because it's cleared for that kind of pressure and force. Be like, what else? Be like, I don't know. I heard it's really empty, right? But on the material science side, they know a ton. Can you build a good space shuttle without the material scientists? Absolutely not. It's nonsense. You'd have nothing to work with. Like sports science in the absence of exercise physiology is just a bunch of guesses about what athletes do, and it seems to work, right? But exercise physiology or material science without space shuttle designers, you've got a lot of cool materials in the research lab. It's like when Batman goes down to like whatever Fox's research lab and he like pokes some kind of gel and it goops up, and Fox is like, oh, I've been playing with that. I don't know what it's good for. And Batman's like, I think it's good for climbing buildings, right? Yeah. So Batman would be like the sports scientist, and Fox would be the guy who's actually the exercise scientist.
The nerd, yeah. I like that. So that you're taking these things and applying them and whatever you're interested in. So I assume from the beginning you kind of focus more on the sports science side of things?
Well, so I first got interested a lot in sports science when I became a powerlifter when I was an undergraduate. And that led me to switch my major to kinesiology. We had no sports science at all at the University of Michigan, as far as I could tell. So I first learned exercise science, which is actually very good. You don't want to learn sports science first. That's actually completely backwards, because you want to learn the deep underlying mechanisms, and then you want to learn how to weave them in, because then it makes sense. But if you learn recommendations, you just sort of have to take them at faith and be like, I guess that's how it works. You might learn them well and be actually a pretty good coach, but you're never going to make really big insights as to how stuff works. Because you don't know the deep mechanisms. So the proper way with education, and all of education, you go fundamentals, and then you build on the fundamentals to do application. So I learned exercise science first. In my undergrad, it was very good exercise science. My master's program with Dr. Jeff McBride was kind of a very bridge the gap between exercise and sports science, mostly exercise science, but a bit more application to strength and a bit more concepts for lifters and athletes. And then my PhD at East Tennessee State, Dr. Stone, was sport physiology. And he legitimately told us the first day, if you're here during orientation, before the first day, he said, if you're here to learn how to help people get in shape or like general fitness, if you're here to learn how to manage pain, or you're here to learn how to heal injuries, you're in the wrong place. You straight up leave right now. We're here to take good athletes and make them as best as they can be. And I was like, holy shit, am I in the right place? Yeah. But if I didn't have my exercise science background, I would have been in a very, very dark place at East Tennessee, because Dr. Stone would assume you knew what the Krebs cycle was, and he'd be like, let's find out how it works in various running events. And you're like, if you're like, what's the Krebs cycle? He'd be like, what? So luckily, he didn't accept anyone to the program that didn't know stuff like that. Some people did know it worse in the year since I had been there, and they very, very much struggled, which they should, right? You got to know the basic. It's like not knowing much physiology or anatomy. It's like trying to be an orthopedic surgeon, but your anatomy's not that great. I mean, holy crap, you're in a real bad way.
Yeah, absolutely. So all this stuff, it makes sense. The same in our world too. You start with the fundamentals. We learn all all the little nitty gritty, and you don't have to know it all later, but you at least understand it enough to apply it. Yeah.
So you can like, my wife's a doctor, so you have to be able to at least read, the stuff that you guys, what is that? That you guys have tons of medical reference dictionaries, and now they're all digital, right? So they get updated all the time. You have to be able to read a reference guide and understand every single term and every single physiological structure. Like if I read it, it's like, renal metabolism, like renal, I guess that's kidney, fuck. Like I could read everything a doctor reads, and like, that'd make basically no sense to me. So you don't have to memorize stuff as what you do in your education, but you don't have to remember all that stuff as a doctor. But as soon as you read a statement like, this is the interaction lisinopril has with this and that, you're like, oh, I know all that stuff. That makes sense to me. And it's funny too, because as you probably remember from your medical education, a lot of people go into medicine, I don't think many of them make it through with a desire, like, I want to help people and be a doctor. It's like, guess what? You have 6 years of pure physiology until you wait, not even, you have 2 years of just chem and bio. Forget about physiology. You can't even understand that stuff yet because you don't even know chemistry. And they're like, there's a bunch of, when I went to school, I took chemistry and all the other classes as a kinesiology major. Tons of my classes were mostly pre-med students. And about the ones that are going to become really good doctors, they're in there getting A+ and all that stuff. But there's some people that are like, nah, why do I have to learn chemistry? Like, I want to be a doctor. It's like, you fucking idiot. Like, if someone has a drug that they're administering, you don't know what a half-life is. Good news, bad news, right?
Yeah, and it's totally, absolutely. And the amount of stuff I tell people, I've forgotten most of it, but I still recognize it when I see it, and it makes sense most of the time. New stuff comes out all the time that with the, biochem and stuff that we don't have to know. But And that's what I was going to ask about is sports science, because you've talked about mTOR pathways and AMPK and all that, and that's probably more along the sides of the biochemical or the nitty gritty researchers doing animal research or doing in vitro studies and all these things, and but you're still taking that stuff too and trying to apply it.
That's our job as sports scientists. That's exactly what our job is.
Yeah, I think it's fascinating. So as far as research, did you just kind of learn did you have to take a lot of statistics courses and all that to do these studies and know how to do them properly?
So before I got to university, I had already had advanced placement statistics, which in the United States is supposed to be pretty good. In my case, I read statistics in my free time because I don't have any friends. And then I had at least one research methods and statistics course, at least one in every single degree program I did. So I had one in undergrad, I had one in master's, and I had one in PhD program. And in my case, because I was a professor for a while, I taught statistics and research methods courses. So the answer is overwhelmingly yes. And there are very few people who get through very rigorous programs who did not, it's not just take these courses, it's take multiple versions of these courses incrementally more. By the time I got to the PhD program, we were learning much more biostatistics and exercise and sports science statistics than we were. So we had 2 courses in my PhD program. One was biostatistics that all the doctors took and medical doctors. And 2 was we had a specific sports science statistics course given to us by William A. Sands, who's, if you Google that name, crazy, overaccomplished, 250 plus publications in sports science, legend. And he had developed and collated many of his own statistical methods that are very rare, but are super applicable to sports science. Sports science has the landscape is often very high degrees of variance and also very small sample sizes. And you're not asked to draw, did it have an effect or not type of conclusions. You're asked to draw, like, what's your best guess? Like, is there a difference between these? Because your volleyball coach is going to turn to you in practice and be like, what are we doing today? Are the girls fatigued or not? You're going to go, well, the p-value says whatever. That means no, but like, the trend is massively in this direction. So it's a lot of trend analysis. So I've been through a lot of that stuff specifically to become a better sports scientist. And I think that kind of stuff is super, super duper important.
Yeah, absolutely. It's something most of us never get. And I think that's what makes it, and that's why we're having this talk today. But that's what makes it so hard about reading papers, because we don't know those things. Us late, and I don't. As a doctor, I know some of it, but it's so complicated if you haven't had those PhD level statistics. So, but maybe could you break down, and this probably applies to all studies, not just sports science, but kind of the hierarchy of good types of studies, what's considered, the least level of evidence versus the
You
highest.
mean just of the individual study designs,
Yeah,
or?
yeah. Just kind of go into
Okay.
that just broadly. What kind of
Sure.
studies are there? Yeah.
Well, so there is a spectrum. People have broken it down in various ways, but it's really a spectrum of purely experimental studies on one end, which seek to control as many variables as possible, introduce one variable at a time into the equation, and they can establish cause and effect. Then at the other end of the spectrum, there are observational studies, which just look at stuff happening and run some correlations and maybe not even, and they can get hints about cause and effect that would later have to be tested, ideally in the true experimental studies. And then this whole band here is what you can term quasi-experimental. Because there are so many different types of experimental controls and so many ways to organize data and look at it, I don't think it's super instructive to look at, like, because I've had many textbooks when they were like experimental, quasi-experimental, blah, 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 and they had 3 other categories until you got to observational, and there was different kinds of observational, like observational with intervention, observational without, and then there's qualitative, quantitative, because you can qualitatively observe, quantitatively observe, they count stuff or say, well, I think this is where it went. So all that stuff we don't have to know. We just have to know that at the one end of the spectrum is a pure experimental study where everything is like white, clean room controlled. We know damn near everything about the study, like subjects, for example. We only manipulate one or several things at a time. We know exactly what we're manipulating, exactly how. And there's very tight control groupings so that we know that what we changed is almost certainly what caused the change, which is how we can do cause and effect. And then you can have worse and better controls, and you sort of slip down the worst controls all the way down until you have no controls, which is an observational study. You don't control a fucking thing. You can impose statistical controls after, but that never really lets you establish cause and effect. It just gives you hints. If you applied a bunch of statistical controls and the effect is still there and still very robust, you're like, man, I really sort of think that we might be onto something.
Right.
Another way to look at this is true experimental studies are hypothesis testing studies. They let you really test if what's going on is going on. Observational studies are best seen as hypothesis generating studies. So, and it's super important. People say, well, one's better than the other. That's not true. They're just for 2 different things, and then they're on a sliding scale. Hypothesis generating studies are unbelievably super useful, because if you don't do those, you don't even know what the fuck to study. Like, imagine if we thought that people that wear red shirts just get more jacked than people that wear black shirts. Like, that was our hypothesis. But if we ran statistics on who's jacked in the gym, we'd notice that there's a difference between who's jacked by gender. There's a difference perhaps by race and ethnic origin. There's a difference by height and weight. But like, shirt just doesn't fucking matter. Red, black, doesn't matter. So our hypothesis generating study about, like, let's just measure a bunch of stuff about people and see who's jacked and who's not, or how jacked they are, that hypothesis generating would return the red versus black thing as just not a viable hypothesis. So if someone said, listen, I want $1 million to test red versus black shirt, like, we're going to come into the gym, one group's going to put on a black shirt and lift, the other one's going to put on a red shirt, and then they're going to get shirts to take home, they have to sleep in black and red, you would be like, why? And they'd be like, well, because I think it's causing the muscle growth. And you'd be like, can you give us an observational set of data that even hints at that? And they'd be like, no. And you'd be like, well, we have this set that says you're a fucking idiot. And then they would be like, shit. So, like, once we do hypothesis generating studies, we get hints and clues. Like, for example, males tend to be more muscular than females. We would do easy observational study. And then you could say, like, oh, I wonder why. And then you would impose more rigorous controls, get in more depth, start to look at individual muscle fibers. Maybe you can even have a study you say, okay, I think it's testosterone that's a big part of the equation. There has been experimental studies, which I'm sure, well, you guys in the group know these, the Salander Basin studies from Texas, where they give various dosage of testosterone to people and they see hypertrophy, and it's a very, very linear relationship. And you're like, oh, this is part of the equation. But before, we knew about testosterone, Salander Basin would never have done these studies, because you'd be like, why not just give them soda or bagels or something else? How do we know it's testosterone? Well, from observational literature.
Gotcha. Okay. And kind of on that, not in the same vein, but you talked about getting these studies off the ground. How hard is it? I mean, how many studies don't ever get off the ground? And what I guess, first of all, who funds all these studies, especially in sports science world? Is it academia? Is it government studies? Is it private Reebok, Nike? I mean, how does all that?
It's a combination, right? So some universities, many universities, give each professor that is tenure track and has a research line, right? He's responsible for doing, she's responsible for doing research. They give them some amount of money every year to do research with, and it's usually just not much, right? And then another is you can write in the United States, for example, and there's concomitant organizations in Europe. You can write in to get a research grant from the National Institutes of Health, for example. Now that requires a little bit of, there's a reason I don't ever write grants. It's because the entire process makes me sick. You gotta how am I gonna say lie, but you gotta you gotta layer it in. So for example, I have friends that are neuroscientists, and what they want to do is they're the exercise science equivalent of neuroscience. They don't so much immediately care about how to make drugs that make the brain better and heal disease. They just want to understand how the brain works, which, by the way, is going to lead to almost every miraculous invention in the next 40 years, right? So it's very, very worthwhile. It's hard to get funding when you say, I just want to learn how the brain works. So what they'll do is we're trying to study this, this and that inhibitor and this and that gamma neuron, and Alzheimer's has something to do with that. And the study NIH reviewer will be like, Alzheimer's. Yeah, okay, great. We'll give them money, right? So sometimes you got to play that game of funding with the National Institutes of Health. And to be honest, I'm actually not a real big fan on a philosophical level of exercise and sports science being done with NIH grants, because for the love of God, people are still fucking dying of AIDS and cancer. We make more money for that, and you can learn how to lift weights in your fucking garage in your spare time. People have asked me this before, do you think the government should have more money funded to study hypertrophy? I'm like, no, less. I'm telling you this, as little as possible. None. Is hypertrophy's it's outside of various applications for degenerative disease, which are very small compared to a bunch of other diseases we have. It's just a very moot point, right? It's entertainment, right? For the most part.
Yeah.
So that is to say, people who are involved in hypertrophy studies usually have to get their money elsewhere. So they have a little bit from the school. NIH grants come through every now and again. These are very small. Private funding organizations give various amounts of money, and it depends on what you're studying. So a lot of times supplements are very easy to study because supplement companies will just pay you to study them. Just be like, hey, here's $10,000 to study our creatine.
Right.
And that's usually just pretty straightforward. But Jesus, how many supplement studies can you do, right? So to get general studies, you have to go around and look for government funds and look for school funds and look for private funds. I'd proudly say, wave the old RP flag. RP gives dozens of thousands of dollars every year to research, so people can do research, so we can find out how to get more jacked and stuff. We don't give it to medical research. We give it to getting jacked research, because we need that research as a company to make better products for our clients. It's like win, 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 win. There's not a ton of companies like ours, but there are a few. And another good thing is that research in hypertrophy, especially training studies, they just don't cost that much money. You get volunteers. They come in, they want to train anyway. They get free training. And the most expensive thing is, hypothetically, is the time spent by the practitioners teaching them how to lift and making sure they lift. But that's often students, so that's just part of their work study, so they just don't get paid anything, and they just do it because that's part of your degree, right? The professor already gets a salary, so he's there anyway. And then, the next most costly thing is having a lab in which to do the lifting and do the analysis. Most of the time, the university establishes and pays for the lab anyway, so that's sunk cost. It's totally handled. And then on top of that, sometimes the assays and various tests get a little bit expensive. Measuring intramuscular proteins of various kinds, you have to send them off to a different lab, and they have to fraction everything out, and that can cost a little bit of money. But usually, people get that sort of thing covered with the various other sources of funding that I've described. So it's by no means easy to get funding. But the good news is that a lot of studies end up happening because it just doesn't cost a ton to do hypertrophy studies.
That makes sense. Yeah, I assume it'd be very different if you're doing biochemical research and cellular stuff and all this crazy. Yeah, that's totally different than you're talking about.
For sure.
How do you, since you mentioned who's participating, how do y'all do just how do these studies work as far as recruiting people and just getting it all together off the ground? How do you find your subjects and all that? I'm just curious.
Sure. So usually it depends on who proposes the study. It's often a graduate student will propose the study to his faculty advisor. And the faculty advisor, she'll be like, well, that does sound like a swell study, except it's way too ambitious. We don't have the money to do this. Or she'll be like, that's cool, but it's not ambitious enough, and we have a little bit of money, so why don't we also measure these 3 other things? they'll tweak it a little bit and they'll come out with a study design that everyone sort of approves of. And sometimes the study design comes top down from the lead professor, sometimes it comes from another faculty member, and oftentimes it comes, probably most times, from the graduate students themselves and the professor sort of, because you want the graduate students to be really in charge of the study, because the professor might have multiple studies going at the same time. You want people to take ownership for it.
Yep.
So the graduate students and the professors have the study, and what they do is they lay out every single detail of how it's supposed to be conducted, and they make sure that all the equipment they're going to be using, they have. They make sure all the funding is there, so that they know how to pay for all the equipment and pay. Sometimes they pay the volunteers. So I don't suppose they're volunteers at that point anymore. Yeah. Sometimes they pay the research subjects to come in and lift weights or whatever, and then there's subject recruitment. 9 times out of 10, perhaps more than that, you just put up posters in various university recreation, like athletic clubs, and or make announcements in your classes that you teach, or go to other professors' classes that have big classes like Chem 101, Bio 101 with 500 students. And you say, hey, listen, you want a free personal training? You can, for 8 weeks during the semester, you can just get trained, and we just need to poke you once or twice and you're good to go. Sometimes it's like we have the blood draw at the beginning, blood draw at the end. You get to max out and that's it. So people are like, that sounds really great, right? And sometimes when you pay them $200 for the whole 8 weeks, they're like, oh, sweet, that's like cool drinking money, right? So that's really how you recruit subjects, and most of the time they're just undergraduates in the university. And sometimes a couple grad students sneak in. Sometimes your recruitment can be just people in the community as well. Jesus. I've been involved in a few studies where people from the community means like folks that wander in, and we're not allowed to discriminate. So especially when you pay the money, like, we do some studies with like various nerve impulse tests, which are acute studies. That means they come in once, they get a test, and they leave. And we've had folks that were like, yeah, they were on drugs and possibly without a home, but they sure made their $50 and not invasive. Yeah. And sometimes you actually, they have to be of competency of mind to be able to sign a waiver. Right. And some people, I have no idea how they got past that part, but they sure did. And mind you, none of these studies are like, there's zero harm whatsoever. Right. It's just like, hey, like max out on a calf raise and then go home. Yeah. But so sometimes you get some odds and ends and quirks. And a lot of times the researchers will want a more clustered statistical sample so they can conclude more. Not too much variance can sort of poison the well. So if they'll say, if you're between 18 and 30 years old, we'll take you. But if you're 31, yeah, you're a grad student or you're a professor, but like that's really, we just want a condensed population. So sometimes even if you have more volunteers, you might cut some of them off or just not let them enter to keep that study sample rather homogeneous. The more homogeneous your study sample, usually the better, because whatever it is you want to find out, there's less statistical noise and everything settles down, and then the effect you're actually looking for becomes more clear.
And that's what I was going to ask next about which I was going to ask later, but we can go and just talk about a lot of these studies we see are on untrained individuals, or elderly people, or what can we draw from a lot of these studies on untrained people, as most of us that are looking at this stuff at this point in our lives are probably intermediate lifters. I mean, I just, versus trying to find people that are, they're 2 years into lifting. Like, what is I don't know what my right question is here, but what can we draw much from those studies with untrained individuals?
We can draw a ton, but there's a bunch of stuff we can't draw. So I think it's very pertinent to talk about what we can't draw. Specific workout routines and applications for anyone other than beginner lifters are a bad idea to draw from beginner lifters. Yeah. What is really good to draw from beginner lifters is basic physiological and training response mechanisms. For example, you take a look at some studies that find that if you train a ton, you get mostly muscle damage and pretty much no growth, because the damage takes away from the recovery and adaptive capacities. Is that same amount, you could see, like, you look in it and it says it took 5 sets of squats to get there. Anything above 5 sets is just pure damage. It would be stupid as hell to be like, never do 5 sets of squats or more because it's pure damage. This study found it. Yeah, it's found it in people who have been training for 0 weeks. Right. You're going to be able to do 10 sets or 15 sets until you hit that point. But here's the cool kicker. That point exists for all biological organisms. That point exists is a huge revelation, because you'll have people on the internet, bodybuilders right now on Instagram, being like, this thing is too hard, it's just under eating. Like, well, that's fucking wrong. So if we understand that we take people who have been training a couple of months and we train them, and there's so much training you can do that's too little and they don't grow at all, then we take people and train them as much as possible, and we realize there's a limit to that. We know these 2 limits exist. And these limits might be this for beginners, and they might be that for intermediate, and they might be that for advanced. So practically, you don't want to say, well, it's this number of sets or it's this much weight. Exact protocols you almost never want to extract from this, but underlying deep mechanisms and processes are absolutely, they're going to be pretty close to the same. No, your cells don't change as some kind of fundamental. You still have mitochondria, you still have a nucleus, you have all the same stuff. For example, mechanisms of growth. You could say, okay, how does muscle grow? In the first 8 weeks or 10 weeks, it might grow by a slightly different pathway. But if you realize that, myostatin is somehow involved, MyoD is somehow involved, a bunch of various regulators, mTOR, AMPK, so on and so forth, we have a rough understanding that very similar mechanisms, though maybe in slightly different proportions, are also going to be involved with intermediate lifters and also advanced. So if we know that some kinds of training increase them in some ways, we could have a hypothesis, again, that could eventually inform advanced training, but very carefully. So in another sense, you could say that training studies, even experimental ones, on beginners are a great hypothesis generator for advanced. But they are not a hypothesis tester for advanced, because only training and testing the advanced people will test hypotheses for the advanced.
Now that makes sense. So you could take that and then say, hey, let's apply this to a little more intermediates. And then start with that volume and then bump the volume up, whatever you're doing.
100%. General relationships.
Okay.
And that's really as far as you'll ever get in most study application. Because for one really big reason, even if you try to get tons of specifics out, inter-individual difference between advanced people runs the gamut of all those anyway. Right? So what you can do is general relationships get you a real good part of the way, and then the rest of it has to be individuals. For example, James Krieger has done a review of literature, which I'll talk about later, how great reviews of the literature are. And he found that, in the studies with lots of untrained individuals, quite a bit of intermediately trained, very few advanced trained individuals, found that roughly 8 sets per session seems to be close to maximum adaptive volume, the most you can do in one session and grow. Don't just say 8, number 8, that's it.
Right.
What it's great about that number is you think, okay, I know 2 things from beginner studies now. One is that over the course of the weeks, people recover and adapt more rapidly and better, so that the amount of volume they can both do and recover from and probably benefit from goes up. We know that. So advanced people might be able to do more volume than beginners. We also know that advanced people are much stronger and can disrupt homeostasis more, so they might actually not need as many sets to do the same thing, but as you would think, because they definitely need more stimulus to grow, but they're so much stronger that per repetition they get more stimulus. So maybe those two sort of roughly cancel out. And then that something like 8 sets has been found in this group of people, mostly intermediates, to be close to optimal over the long term in study design. And you also see robust growth from anywhere between 2 to 3 sets per session, all the way up to depending on the study, 15 sets per session. So if someone came to you and you're like, okay, you're an advanced lifter, let's do 20 sets per session, you might not say that's a terrible idea, but you might say, gee whiz, man, I don't know if I'd start there. Mm-hmm. And if someone came to you and said, listen, you're advanced, let's start at 1 set per session per muscle group, you might be like, man, if beginners after several weeks only grow their best from 2 or 3 at least, I just don't think advanced people can do 1 set and grow the most. So if you're training advanced folks, you might be like, look, we'll start something like 4 sets per session, and anything north of 15 we're going to get real skeptical about. But that's really good advice, though, because what do you do with it later? You're not like, whoa, that's fucking stupid, Dr. Mike. What am I supposed to put in my program? Is it 4 or 15? That's fucking 11 sets apart. Well, start with 4 and auto-regulate to see how you're feeling. Are you getting sore? Is your performance improving or decreasing or stable? Are you getting good pumps? Are you feeling the muscle being fatigued? If you're checking all the boxes as I don't feel shit, then you probably need more. If you're checking all the boxes I'm going to fucking die if I repeat this, then you're probably doing too much. And now you can constrain yourself and maybe land at 12 or maybe land at 6 or maybe wherever as your average per mesocycle optimum. Well, that's awesome. And because we knew that 8 was a number and we knew all the stuff around it, we had a real big help. We don't have to waste our time with looking up old, Flex magazine routines. They're like 30 set guide to bicep training. You just throw that shit right in the fucking garbage. That's almost certainly wrong.
Yeah. So that's important for these guys to hear, because I mean, I am a member of like the Revive Stronger Facebook group, and I'll read all the YouTube comments and all this, not all of them, but people, they latch onto these numbers and they say, oh, we got to do 45 sets because that's what this study, and they need to hear this, that it's a range, and this is just how these things come about, and you got to still individualize it. So
sure. And the way that really you can start to individualize and understand that it's a range is by looking at multiple studies at the same time to try to draw conclusions.
That's what I was going to ask you next, actually, was what do we take from one study, 2 studies versus 10 studies? We're always looking for, I guess, being able to replicate findings.
The lost art of replication.
Yeah. I mean, how hard is that? What makes, I guess, sports science so hard and sometimes replicating these things? Is it because there's so many confounders between the way studies are designed, or between the individuals, or is it what the researchers are looking for? I mean, are they going in with a certain angle? And there seems like a lot of conflicting evidence. It's sometimes hard to replicate things.
Some of the problem with replication comes from people's intentions. A lot of times people want a cool new study and they don't want to replicate. Sometimes their funding and approval process is biased away from replication. That's actually a problem that's getting some attention now at the national level with the biological and psychological sciences. Unfortunately, the NIH and other granting bodies are less likely to grant something that says we're trying to replicate this study, because they want new fancy shit. Which is fucking stupid, wrong, and completely anti-scientific. The good news is you don't need exact replication all the time, especially in our field. What you need is studies that, here's the first study that's been done, and then this next one lands here, and this one here, and this one here, and this one here, and this one here. It's all slightly different angles and approaches, but we're going to learn a lot about this bigger circle during that time. So you might think, okay, what does failure training have to do with muscle growth? You may get one study that does failure training twice a week, one study that does failure training 3 times a week, another study that does 2 reps past failure, another study that stops 2 reps shy of failure. And then let's say we replicate each one of those studies 3-fold, like there's 3 of each. Well, each one of those groups of 3 studies is about completely different shit, sort of, but it's all around that failure landscape with some different frequencies. And when we look at all of those studies combined, we're going to try to read what the general consensus is between them, because we're going to have some weird differences, and we don't super care about those for now. Eventually they can come up. But we're going to be like, okay, what is the sort of overarching theme in all of these studies? And you start to look at it and say, okay, if we train pretty far away from failure with high frequency, that seems to work pretty well. And that makes sense because we need the extra recovery, because if we do high frequency to failure, we're trashing ourselves. But then you look at lower frequency studies, and it looks like even going beyond failure is just as good as going to failure, and a little better than going just shy of failure. And you're like, well, that makes sense because you get a huge stimulus, but it's low frequency, and then you have time to drop the fatigue, so all is well in the end. Those kinds of big relationships are fucking impossible to get from one study. And which is why one of the many reasons why one study means hardly shit, which is what I try to get across to Lyle in our discussion. Yeah. But I suppose when you arrange a podcast specifically to talk about one study, you, at face value, don't agree that one study is rather moot. So the thing is, if you've actually done research, you know how tenuous and unfortunately unreliable single studies can be. There have been many, many instances, not proportionally many, but numerically many, where master students fudge or make up data, where professors fudge or make up data, where your EMG was broken the whole fucking time. You had no idea. When you improperly place EMG leads and you get mostly just static feedback, and you say no differences were found between groups because you can't fucking detect them anymore, and all the way down the line. Now, those are not biasing factors that present in a distinct way in every single study. They basically cancel each other out, but there's noise. So any one study has a lot of noise to it and potential for just its results being total bullshit or the fucking God honest truth. When you have 10 studies, the bullshit goes like this, blah, 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 and it cancels itself out, and then whatever arc weaves itself through all of the studies, or most of them, no, man, you're pretty sure that's onto some real shit, because people don't usually bias their studies or make random errors in any specific direction, right? So once they cancel themselves out, now you're starting to really get a good look. One study, for all of those reasons, means very, very little. I would actually go so far as to say that one study is only and always, almost always, hypothesis generating in nature.
Yep.
When you have 5 or more studies largely telling you the same thing, you're now getting a little bit from the hypothesis generating end of the spectrum to the hypothesis confirming or refuting or understanding end of the spectrum. And then when you have 10 studies, 15 studies, 20 studies, you're starting to really understand the dynamic. And no one can say, well, that's based on this one study. Like, no, it's based on all of them. You know, say, well, how many of the studies agree with the result? You know, 18 of 20 show this. Like if you have, imagine you had a study where you were trying to see if males or females were stronger, not adjusted for any kind of coefficient, just straight up, can they bench more? You know, you throw Priscilla Ribbick, Marissa Inda, into one of those groups, and they're going to bench more than every guy in the fucking study, and they'd be like, see, females are stronger. That'll be one study, right? And then one of the other studies will have, you know, a male that's a power lifter and all the females are recreationally trained, and the males will look 15 times stronger.
Right.
So, you know, you could have a study with people like Chad Wesley Smith and people who are untrained females and be like, men are 100 times stronger than women. You'd be like, no, they're fucking not. Right? You could have another study where, like, man, you know, women are on average a bit stronger than men because Marissa Inda's in that group or whatever, and so are some other female powerlifters. And remember, because a lot of this is volunteer stuff, people come in and, you know, the females you might have recruited just all on the Texas powerlifting team, and it just so happens that you're like, well, we take all people with 3 years of training, except they trained right for 3 years, and you got other like Jim Bro who's been training dumb for 3 years. They're in the same group. Then all of a sudden, females look stronger. So what can you learn from that? Well, just not much, right? But if you have 20 studies, all those weird things are going to cancel each other out. The men are 10 times stronger. The women's going to cancel out where the women are stronger than men. And then the average vote is going to be like, well, you know, men seem to be quite a bit stronger than women, specifically in these following ways. That you can probably take to the bank. And there's never absolute truth in science. There's only incrementally walking towards the truth. Like if you have 5 studies that say roughly the same thing, you're like, wow, this is really interesting, definitely worth some attention, and I'm certainly going to try this because I don't want to be left out. You got 10 studies saying the same thing, man, it's tough to argue against. You got 20, you're starting to get a pretty deep understanding of what's going on. You got 100 studies, and you have what's probably like if it's a well-done review and the study is fundamentally sound, you got what we'll probably call a research consensus. Like doctors will use 100 study samples to be like, take lisinopril, it's good for your health. Like, but has it been studied on everyone? And 100 fucking studies, it says it's fine. Yeah. And then we get to something comical like studies on artificial sweeteners, where the number of studies conducted on aspartame are in the several hundreds, and almost all of them pointed in the same direction that it's safe. And then people still say, well, what about these studies, you know? And you're like,
one study in a rat, yeah.
Right, like if you don't think aspartame is safe and you base that on the scientific literature, we as a world know nothing about science because there's pretty much nothing we've ever studied that much. Right. So it's a graded spectrum. So, you know, an example is one of these things where people say, you know, what do you think about citrulline malate as a supplement? I think it's promising, but there's just not enough studies, and the balance of the evidence isn't tilted so far in its favor that I'm willing to go on a limb and buy myself a jug of it. 5 years ago, I would have said that, you know, range of motion, longer ranges of motion and training have a pretty good theoretical basis, but the experimental evidence is just not super convincing. Now, with all the studies that have come out, I'd say the experimental evidence is not incredible, but it's very strong, and we have all the same physiological rationale. So, gee, it's probably a really good idea to try to go for longer ranges of motion. So there's all these different spectra. So, you know, as a doctor, when people come see you, they'll say, well, what about this medicine that I'm taking? Or what about this procedure? What are the chances? What are the risks? You don't have the same level of confidence talking about everything. Like there may be a new procedure that's like, you know, like theoretically it sounds really good and they've had some success with it, but they've only done it in Korea and Japan so far. We're doing it in the clinics in the United States now. You may be one of the first subjects. You know, so it's going to work, right? Like, well, you know, we have every reason to believe it will, but we can't honestly tell you that. Whereas another older procedure maybe doesn't have the same results or the healing time is longer. You say, like, we can tell you what's going to happen, but we can tell you damn certain what's going to happen because we've done it 1,000 times. So same idea.
Same idea, yeah. And you got to look for, and that's what I was going to ask about the confounders. Like people need to be able to look at these studies and dive in, not just read the abstract, but look at the subjects and who were they? What were their characteristics? I mean, like you were saying, what if all those studies were a bunch of Chad Wesley Smiths? And then, you know.
I have an interesting comment on that. That's not going to It's a little bit against the grain, maybe. This sounds super bad, so I'll make sure to qualify it. Stephen, make sure to take this out of context and put it on a preview clip.
Yeah, can't wait.
I don't think most people who go to the gym and lift weights should be reading individual studies.
Yeah.
I take medication for various things. I don't read peer-reviewed literature on the medication that I take.
Yeah.
One is because I can't make heads or tails of the shit. I have no way to contextualize anything. I also have no real solid, more definitive way to tell if what this researcher is saying is representative of the literature as a whole or not. For example, there are many, almost every research article, study description has a mini lit review in it, just sort of reviewing what's going on. I've read a bunch of lit reviews over my years in sports science where I'm like, that's fucking wrong. This is fucking stupid. This person has no fucking clue what they're talking about. The study might be nice, but me reading about how they're contextualizing it they're just steering me wrong, right? But I can't do that when I'm completely out of my element and I'm not trained in the specific statistics and so on and so forth. I'm a trained scientist or whatever. Yeah. If someone's like an engineer or they're a marketing specialist, they get great work in their field, but they might look at an exercise science study and be like, fuck if I know what all this shit means. Mm-hmm. So we actually have a shortcut. We don't have to read individual studies. We can consume various reviews of literature, interpretations of literature by the experts. And the good news is you can do it by both. I'll start out with a hilarious example. Lyle McDonald, at least used to before he went completely insane, do pretty good job of summarizing the evidence about a certain topic. He would write an article about it, cite 8 or 10 papers, the major 8 or 10 papers in that topic, and at the end of it sort of explain how all the papers interact and say, hey, listen, this means that you should try intermittent fasting, but here's probably what's a good idea and here's probably what's bad. Lyle's not the only guy. You got Alan Aragon doing great work for a generation about that kind of stuff. Brad Schoenfeld, and 50 trillion other people, of which one of my favorites is James Krieger, who has a literally monthly updated review of all the stuff, and Greg Nuckols and Eric Trexler. I mean, Eric Helms. The list is endless of people that do this professionally. They're super sharp, and they're all biased in different ways. Me too. But if you read multiple reviews from these people, you subscribe to Mass, that Eric Helms or Greg Nuckols thing, you read James Krieger's review, you read Alan Aragon stuff, and so on and so on and so on. If they're all sort of saying the same thing and the way they describe it to you makes really good sense, and it sort of comports with your own experiences with training clients or with just training yourself, they're probably right. But if one of them is saying this weird, kooky shit, then, so for example, Chris Beardsley is a little bit iconoclastic, and so is Menno Henselmans, right? These are two guys who also have their own reviews and write about subjects. They sometimes say really quirky shit, and sometimes they're fucking wrong, and sometimes they're really fucking right and nobody else is. So you got to throw those guys in there into your reading list as well, because they're going to pick up on some shit nobody else does, but there's a little bit of a risk because they could be totally off the rocker, right? Same here in my case, right? So if you read like 3 or 4 of these sorts of reviews and just try to, even just by following people's Instagrams and Facebook, you can get well on your way. Maybe read a textbook on hypertrophy. The one Brad Schoenfeld published is really great. So you can contextualize a lot of the stuff. So you do one textbook on hypertrophy, or the Art and Science of Lifting by Greg Nuckols or Omar Souf, or the Eric Helms Muscle and Strength Pyramids. You read just one of those books, maybe all 3, and then you follow all these guys and maybe subscribe to a literature review or 2 or just read free articles on their sites. Man, you're going to start to get a real good sense of what's going on without ever having to read a single study in depth. If you want to read a single study in depth, my absolute best recommendation for a source is Mass. I forget what it stands for, something applications. And
I'm on their Facebook. Yeah, I don't remember. Yeah.
Anyway, made by a bunch of great guys who really know their shit. What they do is they actually let you go along with them as they peel apart each individual study. They don't do a whole lot of literature reviewing. They do some, but they actually go through very interesting studies they discover once a month and talk about the implications of stuff. So if you really want to learn how to analyze studies, I would just subscribe to Mass and read all their back issues and start reading them now. You'll be really good at analyzing studies. But the reason I don't recommend that to almost everyone all the time is you just might not have the bandwidth or interest in that sort of thing. Fuck if I want to read studies, man. I want to know what's right and what's wrong so I can get fucking jacked and lean so somebody can finally pay some fucking attention to me, for the love of God. I don't have any friends, right? I'm tired of being friendless. Steven knows what's going on, right? I got to pick on Steven every now and again. So go ahead. You turned your mic off. Defend your friendless state.
Yeah, I hear you.
So you just want results, right? And you want science-based results because you're tired of being lied to by bullshit supplement companies and gurus. So subscribing to some of these lit reviews or just reading the Facebook pages and websites of these guys that I talked about, they'll take all these studies for you. Do you have to trust them? You got to trust that they're at least a little bit better than you at collating studies, which they fucking are, right? Better than me, better than everyone. Do they have their biases? Can they be wrong? Yes, which is why you never read just one person. And it's concerning when people read just one person. Lyle has his following of just like Lyle tards or whatever. They're like, Lyle said, and you know, like, no, Lyle's fucking smart and he's right a lot. But sometimes he's wrong, and like when Lyle's wrong, he's like grandiosely wrong, and he always goes down with the ship. It's amazing. He's like, "Fuck you guys! I've been saying this for 20 years, and it's just wrong." Right? So, but the thing is, you don't want to just not read Lyle because sometimes he says really right shit. Back in the day, he used to say almost all the right shit. So instead of just consuming one person, you consume a couple people, and they tend to sort of stay here and there. Like, you know, I'll say a bunch of volume landmark stuff, and Eric Helms and kind of say that's, you know, he'll moderate and be like, it's a little bit too much bullshit for me. Somewhere around the middle there is probably a good measure of the truth. And like if Eric Helms and Lyle McDonald and Brad Schoenfeld and Alan Aragon, if they agree on something, holy shit. I mean, either Meadow or Chris Beardsley comes in and ruins the thing, and it turns out they were all wrong. Very small probability, but possible. Or much larger probability that if you listen to what all of them are like, yeah, that's pretty much a good idea, you'll be right as rain, and you'll never have to read a fucking individual study.
That's what I was going to, I think you're right. And I think we all, in medical literature too, don't need to be, because a lot of these guys, and I know, like I said, I'm not a statistician, but I try to sift through these studies the best I can. But a lot of these guys, they're, you know, whatever, they're doing their day jobs and they're posting Google search abstracts online, and they don't have a reference point for even what that stuff means. And so it's the same with working out and all that. Like you say, that you read the lit review at first, and you got to even be able to digest that before you even go into the rest of the paper. But
that happens in hormone stuff all the time.
Oh man! But what hurts me is, especially with hormones, and this goes into any paper, when you start reading that stuff, and from the get go, the stuff they're saying is wrong. So they're saying we all know that blah blah blah, and you go, that's not true.
Yeah.
What do I make of the rest of that paper? You know what I mean? I mean, I can't throw it out, but
yeah. So sometimes there's gems. I would still read the whole paper, but prepare yourself for a whole world of like, wow, that sucks.
Yeah.
And sometimes it's tough when people are wrong a lot out of the gate, because then you have to double and triple check every assumption they make after that, because you can no longer reliably tell it's true. Right. So I would say is if a paper gets if it gets fundamental things wrong, it's time to stop. Or when I first hired Brano Chavez to be my coach, I actually had like a 2-hour conversation with him while doing cardio, and I just gave him basic physiology questions and basic hormonal questions. And he didn't knock them out of the park. He had to rephrase the way I was asking my questions because I was wrong about how I was asking them. I'm like, okay, sold, right? And then has he been right 100% of the time since we've been working together? No, absolutely not, but more often than not. So this is an excellent investment. But if someone like offhand, if a paper or if someone communicating a paper makes a drastic error and stands behind it, gee, man, you know, you might be better off reading some other shit. And that's not to say that people's interpretation of literature means that they did the actual paper, like the actual study, wrong.
Right.
But, you know, I would certainly look at stuff with a grain of salt. And that's the cool thing of like, when someone conducts a proper literature review, they'll contextualize everything. Yeah. Sometimes they give papers rankings based on how well controlled it was. So if you're comparing just 2 studies, which is no good literature review, but illustrates the point. One study is incredibly well controlled, everything was tons of subjects, very high power design, very good ability to discriminate, using very good instrumentation, so on and so forth. And it says one thing. And then another paper is pretty poor in all those things, and it says a little bit of another, just a slight deviation. You might not say, okay, this paper says one thing, this paper says this, so the truth is probably here. Be like, this really well controlled paper, or let's say series of papers says this. Shitty-ish papers say that, then man, the truth might not be here, but man, I bet it's here and not there and not here. Does that make sense? Like a quick example is, this is way outside the scope, but it's nonetheless science, so it's fun. This is something that I'll say, nobody will believe me. If 1 out of 1,000 people does the Google search, they're going to rabbit hole and be like, holy shit, my whole life was lies. The influence of who parents you, what's called your common home environment, on your adult personality traits is between 0 and 10%. It explains 0 to 10% of variance. Genetics and something entirely different, brain wiring or individual peer groups, explain the rest. And the best controlled studies are close to 0 and the worst are close to 10. So like when you look at that last part, what's your bet? Is it close to 0 or close to 10? Well, when the best controlled studies are close to 0, it's like, fuck me. I'm sure not going to bet it's 10. I'm sure not going to bet it's 50. So, so that's an example of using the better studies to have a little bit more weight of the evidence, which is sort of, I think, what Lyle was getting at with critiquing the Schoenfeld studies. He's like, it's such dog shit that we should discount it completely, which I don't think is the case. But that study had reasonable controls, but they could have been better. There are other better controlled studies that we need to put more stock into. But that doesn't mean we put 0 stock into that Schoenfeld study. And hilariously, that study's fundamental underlying points have been replicated like 5 or 6 times now. So no need to.
Yeah. So what was, and this is not really about research, but the recent paper, I guess this is in the last 3 or 4 months, was it Barboli or the one where they're talking about the Barbalo? Yeah, I read it, and they did a female one and a male, I think, and talking about the sets and how many sets per muscle growth. And some of the hardcore guys came on Instagram saying, "See, high volume doesn't work," and all this stuff. But the issue in my mind was that they were just doing it in one session, and so of course 20 sets in one session is probably not as good as 10 because
so there's a couple of issues. And this is where somebody who has reviewed many studies should be reviewing them, and people should not be looking at individual studies, because I'm going to say these are a couple of issues and be like, I'm going to look forward to the stuff in other studies, but there's 10 other issues I'm not talking about. So just as an example of why a comprehensive review of the literature needs to take everything into account and arrange it so that it makes the most sense. The Barbalo study did 2 things. One, I believe it was a 20 or 24 week protocol. That's no deloads. If I was going to overload for 20 weeks, I would for sure do 5 to 10 sets and not 10 to 20. For the love of God, I would die halfway through. So first point. Second point, it was once a week training for each muscle group, which is to say that's not more pertinent. What's pertinent is just one session at a time. We already know from James Krieger's work that 8 sets for that sort of cohort, somewhere between 5 and 10, we'll say. 8, it is 8, but that's too specific for us to do anything with. Somewhere between 5 and 10 is already the maximum adaptive volume per session. So if you have one session a week, what the fuck did you think it was going to be? Right. So that was the answer. There's 5 was really good, 10 was really good, and everything else sucked. Like, no shit. But if you say, well, that's the most volume you could do per week, you need to qualify it with Brazilian undergraduates aged this and that in that specific sample training once a week. Yeah. Now, if you say that, you're just repeating what the study found literally. But they're like, well, but what about for us? Well, you weren't in that study, you dumb cocksucker. You have no idea if it was going to apply to you. Well, let's take a look at the main features. Well, if you're a beginner and if you're training once a week and you're resting a long time between sets, enough time to really have really super hard sets, yes, 5 to 10 sets per session is something I would be comfortable recommending. But as soon as you're like, well, I train twice a week, well, that study had dick to do with twice a week, so we don't know. But we have other studies that tested twice a week and 3 times a week. So you got to take all the literature multiple times a week, multiple rest times, different populations. And when you collate all that, you start to get a Krieger-like understanding of the whole picture that, anytime you do much more than 10 sets per session and they're really hard sets and you really know what you're doing, you probably just stop and come back another session. But up to 3+ sessions per week probably leads to more hypertrophy than 2 or 1 by a small margin. And thus, if you want maximum results, you could be doing up to 30 sets per week in some muscle groups. And then there's muscle group differences too. People will see a study on biceps and they'll be like, okay, once a week training is the best. So once a week training, for biceps, for Brazilian undergraduates training for 20 weeks on end, right? But if you remove all that scaffolding and just leave the biceps, how do you know chest is different? How do you know maybe legs are different, quads, hamstrings, so on and so forth? So at the end of the day, they can't possibly study all the shit in the laboratory. You have to take the gems and the relationships, the understand the concepts, and apply it to your own training with autoregulatory markers that tell you if you're doing a good job or not. Because it doesn't matter what Barbalo finds. If you try their shit and you fucking suck, something's fucked up. You have to make an adjustment. If you have no way to know if you're making an adjustment, the last thing you want to do is do a study design as your workout and just have no autoregulatory feedback. I have no idea if it's working. Do it for 20 weeks and be like, it didn't work. You never thought to adjust it. Imagine you did the Barbalo protocol verbatim and you're like, I got pretty sore for 2 days. And then I just wasn't sore at all. And I was super recovered the rest of the 5 days of the week. And somebody could be like, didn't it occur to you could just train again? Nope, they only train once a week. You're like, right. So, or they'll say something like soreness doesn't matter, which is like a hilarious thing to say, like at all? Like, no, like, so if you're so sore that you can't physically train hard, that's okay. You're still growing. They're like, yeah, like sweet. And if you never get sore and you're doing teeny tiny volumes and you could be getting way more volume in, do you still not increase? Like, no.
Yeah.
Yahoo.
I love it. So I guess one thing I wanted to kind of not wrap up, but just bias in a lot of these studies. I don't want to say a lot of people are trying to deliberately mislead people, but I mean, when you look at like, there's certain, and this is more probably on the nutrition side than the sports science side of fasting is better than everything else, or look, insulin makes you fat, or all, you've got these guys that are zealots. Most of them are trying to sell something, but how do people how much is that in the industry as a whole? How much bias is there? How often do you think people go into these things with an agenda to prove something they already are hoping is true? I don't know. It's something people need to think about. I think that there is bias with
the good news is it's a small amount of bias, and the other good news is the bias is often countered by other people's bias. So you got pro keto people doing research, and you got pro vegan people doing research, and on a net balance, their most extreme, most bullshit studies cancel each other out, and we just take a look at the average.
Gotcha.
The other piece of good news, it's actually very, very difficult to falsify a study completely. What you would have to have for that is a whole team of graduates and undergraduates helping you that are okay to go along with a lie. And gee, that's rare. Whistleblowing is easy. It's anonymous, and it gets you a lot of reputation. And most of the people involved in science really love science and really don't like making up bullshit. So they're keen to that kind of stuff. Most of the scientists have ever met nutritional research. They'll gladly take money to study various supplements. But they will never in a million years, like if a CEO is like, hey, make sure the results come out good, they'll instantly report them and get tons of recognition and appeal. And most of the supplement studies I've been involved in quite a few, show no effect. And then the company isn't even pissed. They're like, nah, okay. And they just try to go and either they won't talk about the study, but the study's published. You can find it. They're just not going to post it on their website if it goes to hell. So where I wouldn't get my science research is like on Optimum Nutrition's website. Bad place to look for science, right? But, PubMed's got all the studies ever done on protein, and some of those don't come out so well, or creatine or whatever, or supplement. Sure. So direct explicit bias is pretty rare. Implicit bias can happen, but then again, it's largely sort of mitigated by both directions. So for example, I believe Lyle accused Brad of basically being like a big volume backer. But the thing is, Brad's own study refuted his own recommendations, making him look like a fucking idiot. You really think you want to do that? He's been saying for years that roughly 10 to 20 sets is good, and then he has a couple of studies come out that say up to 45 sets is good. Why the fuck would he do that, right? And then so let's say there are people who are big on volume. But there's other people that are big on HIIT, super low volume, and they're going to make some studies that are possibly straight up lies, possibly statistical malfeasance is going to occur, and possibly just poor interpretation. And then those studies are going to look wacky. These other super high volume studies are going to look wacky, but then you have the average in the middle, which is rather good studies, and that really tells you what's going on. And one thing we can take from this that's really insightful is and it's the opposite of how news media works. News media focuses on the one extreme study that says crazy things, and they're like, whoa, milk's going to kill you. In science, when you find studies that are real wacky and you're doing a proper literature review, you actually discuss in that literature review, this study found this, but that's awful strange, and we sure need that to be replicated by another laboratory, not the same researchers. Because there has been times where in our own field, research has been biased. Jacob Wilson from Florida just straight up made up a whole bunch of shit, right? And he got canned for making up studies. And the thing is, in most other labs, they were finding that HMB, the supplement, had very small effects or undetectable effects on muscle growth. And his study found it was more powerful than steroids, and they did it 3 times. And it's man, the stuff coming out of Wilson's lab is just all real rainbows and roses for some reason and nowhere else. So you don't have to know that as a consumer of evidence. You just have to know that if one study comes out or if 2 studies come out from the same lab and they say some stuff nobody else is saying, I just wouldn't put much stock into that. That's our best factor against bias, is to not Because what would have to happen is everyone would have to be bought into the same philosophy, which almost never happens. Unfortunately, it does happen in the social sciences. Almost everyone there is on the political left, and it's just total nonsense coming up. They don't really even do research anymore. They just make stuff up.
Yeah.
But outside of situations like that, like certainly in the sport and nutritional sciences, there's no like everyone agrees that needs to be hush hush and we really need to make people think this. So at the very least, what you'll get is one group of people saying this and another group of people saying that. And then you'll look at it and be like, okay, let's find some common ground and some not insanity. But most of the time, the insanity is on the edges and the normalities in the middle, and you get like normal distribution if you were to graph study ridiculousness. Like some studies are very, very well controlled. Most studies are decent, and some studies are just clearly they just made the shit up, right? And then what you do in a good review of the literature is you just mostly look at the middle and be like, it looks like the supplement probably works pretty well. Does it work steroids well? Probably not. Does it hardly work at all? Like these guys say, maybe, but probably not. And you just sort of look to the middle. And I think that's where it's from.
I think that's important for everybody to know, that to look at the more you have, the better. Meta-analyses, literature, reviews are going to be a lot more relevant. If you don't really know the science, you can at least usually trust that more than just trying to pick papers apart.
Yeah, because it could be you're picking apart a wacky paper, you could be picking apart a great paper, you have no idea. And the thing, there's the concept called, how representative something is of something. There could be 170 papers on milk protein ingestion and cancer rates, and you're just looking at one of them, and it was a weird, wacky one that for reasons you know or don't know just doesn't apply to anybody else, right? Maybe their dose of milk protein was to the cell instead of to the organism, and maybe they basically bathed the cell in like a toxic level of milk proteins where the amino acids are literally acidic to the DNA and start to break it down, and then you get cancer. And you can be like, well, see, this paper says like, well, how do you know that this paper is something like what other papers have found? You don't. Which is why most people don't need to look at studies. Most people need to go buy a textbook or have trusted authority who does reviews of the literature. The great thing is in medicine, this process is very formalized. Like the American Medical Association and a bunch of different governing bodies and publication bodies publish comprehensive reviews all the time because doctors literally have to use them. So, if you're looking at like blood pressure medication and you had a patient in your office that had high blood pressure, you go back and see, well, which medication is good for this demographic and costs and benefits, and he's taking another blood thinner, so which one? You have like 5 lit reviews under every single medication that you can look up, and there's a consensus statement about each one of those. Unfortunately, in sport and exercise science, we don't have anything that formal, but we do have those guys that I mentioned earlier who publish stuff like that gets you a really good.
Yeah, it's similar to like, I'm a urologist. We have the American Urological Association. We have guidelines for certain pathologies. Are those 100% right for every person? No, they're guidelines. But when you go read them, they're huge papers, and they've referenced all these other papers. And so it's things like, it's the same you're talking about with the lit reviews and the systematic reviews, that they've taken and collated all this data into something that's a little more comprehensive that you can probably trust. It may not be 100%, but
starting point.
It's a good, exactly. So awesome. I think I had one other question. Well, this was about so let's say somebody, and I have friends all the time, they'll message me, what about fasting? Jason Fung, whatever his name is saying fasting is it, so why is that more just a thing that people latch on to the sensational and they grab what somebody's saying without ever looking it up? Because you can look up these studies and find the comparisons real easy, and it may be the same in the body.
You can, because you're a doctor.
Right. Yeah.
Maybe they can't, or maybe they don't want to.
Yeah.
Most of the time, I'll tell you, I've said this in other podcasts before, but not often. When you ask someone, hey, what do you think about this new thing you heard about? You can automatically just kick yourself in the dick for it, because that is not philosophically how we understand the world best. The things we know about best in the world, the most reliable things, are not the new quirky things. They're the old tried and true things.
Yeah.
Unless you're at the cutting edge yourself and can contextualize these things, then you can select new things. You're probably not missing the boat. And Western medicine and the scientific community is not so nefariously aligned to prevent you from knowing the truth, right? They just have a hard nose about making sure they're well convinced before they recommend stuff. So you think, well, Jason Fung says fasting is great. What do you think about that? I'm like, why would you think there's some kind of trick or hack? And they're like, well, I don't know. Like, do you go to your auto mechanic? You're like, what do you think about this really crazy new mod? He'd be like, I don't know. Nobody's done it before. We're not sure if it works. Do you're fixing a fucking station wagon? Do you really think you need a new mod? And you're like, well, no. But if you're a race car driver, you can ask yourself the question of what do you think about that new mod, because you know how to contextualize it, because you really do need that elite performance, right? So a lot of times when people say like, oh, what do you think of, and they have this weird new thing, the best response to that is, why do you want weird new things? Weird new things are probably wrong. They're probably wrong out of the gate. Right. Yep. You know, sometimes there's some good stuff in the weird new things, and you can say, well, you know, it looks promising. But the reason it's a weird new thing is because we haven't done enough data on it. All the promise could evaporate. There's been multiple promising things that turned out that the more research you do on them, the more they turn out to be not so promising. And it's a lot of times, the first couple of studies are only published because they're super exciting, and the researchers are like, whoa, we found this weird thing, let's publish it. You also get the file drawer effect in research, and it's overstated by many people. But sometimes you don't publish studies that don't say exciting things, and you're more likely to publish studies that say exciting things. Right. So the amount of new and exciting shit in all of studies overestimates the amount of new and exciting shit that's going to be confirmed 10 years later. Gotcha. If you just go by headline study at a time, things are way seemingly more advanced. Like if you go by like 1990 or 2000 headlines about technology development, you would think we're for sure all robots by now based on how fast that shit was going. Yeah. Which was like, scientists discover quantum computing works, and it's like, okay, how far away is it from actually being useful? And then the next article is like, some people think quantum computing may never be useful because of its nature. You're like, well, fuck. And if it is, it's going to be in 20 years. I'm like, fuck. Yeah. I thought it was going to be like today.
I saw it yesterday on Facebook, you know, little ads pop up. It's like, you know, Chinese have found a way to upload instructions to your brain. And, you know, everybody's like, oh, crap. You know, I mean, and stuff like that. So.
Yeah, it turns out a monkey, like, farted when they pressed the button.
Yeah, like, exactly.
Okay, we're well on our way, right?
I say the same thing you do, because I have patients that'll ask me, what about this newfangled whatever, or what about Nugenics, or what about, you know, this, and, you know, with supplements, most of the time I'm like, hormonally, if it worked, it'd be illegal, so yeah, you're wasting your money. Sure. But if it's new and it sounds flashy and it's the latest and greatest thing, because I hear it all the time with prostate surgeries, and somebody's come out with a new little gizmo to avoid something. And
do you want to be the first guy with that gizmo in your dick? I don't know.
Or what if I tell them, I did those. They suck. They didn't work. I don't care what the company's telling you. It's, you know, and there's a principle behind it, and you gotta know that. But a lot of people do just latch on to the latest and greatest, or magical fairy dust thing.
Children latch on to the latest and greatest. Children get excited. If you think of the world as a child would, get ready for the kind of results children get. You know, last thing I checked, children are wonderful, but they don't exactly get results. Yeah. Right. You're like, all right, we need something important to happen. Let's put a child on it. That's just not how life works. So if you want to be an adult, that means you're patient, you know?
Actually might work better in Congress. I don't know. Yeah, we won't talk about that.
Well, you will get all kinds of zany new laws.
That's right.
Man, I remember, this is a funny, I got to go in a sec, but I'll share this stupid story. I was like, this is how nerdy I am. I was like 10 years old, maybe 11, and I was watching morning TV before going to school. And like there was like a yogurt commercial where like, what if a kid got elected president? And there was like a rally with like little kids, and the kid was like in a suit, and he was like, first rule, no, or like first law, no more school. And the kids were like, yay, and they were cheering. And I was thinking like, no more school? How the fuck are we supposed to learn stuff and build the world? What the fuck is wrong with you? How do you think toilet paper is made? Like, you need school. This is the stupidest shit I've ever heard in my life. If that kid was president, I would fucking assassinate him. That would be my job as a kid.
I love it. I love it. Hey,
did you think that we'd be talking about assassinating children?
No, I was going to say, somebody's going to take that out of context and plaster it somewhere and see Dr. Mike sees his
Steve, I want you to cut out the assassination of children.
No, that's got to be the intro snippet to the video. You know, assassinate kids. Yeah,
child political assassins.
Oh, I appreciate you coming on, man. This was awesome. I think this will be helpful for and more towards the sports science side of things, because, like, you know, we know a lot of the guys are trying to dig into these. They latch on to every new paper that comes out because it's all over YouTube. Everybody's like, oh, latest study on volume, but they need to take the bigger picture. And I think this definitely helped that.
Okay. This was awesome. Thank you,
Mike.
Mike.
You guys so much for having me on. Jordan, pleasure meeting you. And it was I thought it was a great conversation. So
absolutely.
Thank you so much.
Awesome.